looking at Module 1, Lesson 16, from ratios to rates. A lot of what we're going to discuss today is going to sound very familiar because we've covered it all. We're just going to look at it from a different perspective and apply it differently. I'm very lucky because my husband does all the food shopping. I hate food shopping. He goes food shopping, but it's also good because he's a very smart shopper. He'll stand at the store and figure out what's the better value. Which one should he buy? Which one is he getting more product for his money? He'll look at the circulars, compare prices, but it's not enough just to compare prices. Let's take a look at these two price tags. When you go to the supermarket, on the shelves, you'll see price tags similar to these. And you see the price. This is $2.59. That's $3.09. So right away, everybody's going to grab that one because it's cheaper. Woohoo! Save 50 cents. It all adds up. Absolutely. However, is it really the better value? On these tags, you'll see something else. How do we know for sure that, let me rephrase another question, I'm sorry. What would I have to consider before assuming $2.59 is a better price? What do I have to think about before I grab those boxes and keep pushing my cart down the aisle?
How much grocery is it per pound?
I have to think about how much product am I getting. Is this a smaller box? Is this a bigger box? And we all know, too, the size of the box doesn't necessarily. How many of you have opened a bag of potato chips and, you can reach all the way down into your elbow before you get a chip, right? So it's not necessarily the size of the box or the size of the bag. We have to think about how much we're getting per ounce, per pound, whatever we're looking at. So these tabs will have a second price on them over here. That tells you how much it is per pound, or I might say per ounce. But now we can compare them more evenly, just like when we did the problems with the lemonade and the paint and the iced tea and the fertilizer. They're easier to compare when they have something in common. So this is $3.09 for 7.5 ounces. This is $2.59 for 5.3 ounces. I said it's really hard to compare 5 ounces to 7 ounces. Wouldn't it be easier if I could compare it per 1 ounce? Or in this case, they scaled it up to a pound. So now looking at the price per pound, and remember per is one of those ratio words. Looking at it per pound, which is the better value? Is this one for $2.59 still the better value? This one is the better value because that's only $6.59 per pound, where the other one is $7.82 per pound. So really, you're spending 50 cents more, but you're getting more for your money. Okay? If we scaled it up from 7 ounces to a pound, that would have been our price. If we scaled 5.3 ounces up to the pound, that would be our price. So that's going to be the focus of our lesson. Okay? So this had a ratio of 309 for 7.5 ounces. But then we scaled it up. What was the value? We had to look at the value. So let's continue with that. Let's take a look at number 1 in your notes. Here's my other bad thing, my Diet Coke. I'm so bad for you. But Diet Cola was on sale last week. It cost $10 for every 4 packs of cola. So how much do 2 packs of Diet Cola cost? So I know that it's 4 packs for $10. Draw this table on your notes. If it's 4 packs for $10, how much would 2 packs cost? So let's scale it down on our ratio table. If 4 packs were $10, 2 packs would be,
20.
no,
5.
5. I'm scaling it down. So instead of 4, I want 2. How much does 1 pack of Diet Cola cost? So let's scale it down again.
2.5.
Right, $2.50. Excuse me. Yes.
For some reason I don't have the.
You have to draw the table. We're on page 68.
I don't have that. My goes to 66 to 69.
You might have had your last homework on the back. Problem said 15 was on the back, so check your take home folder. You may not have put it away. If not, take out a piece of loose leaf paper and you can just copy it on that. You'll be fine. All right. So 1 pack costs $2.50. All right. So what is the value of this? What is the value of the soda? What is the value of that ratio? Yeah, $2.50 to 1. Or $2.50 to 1 since we write value as a fraction. 3 vocabulary words that you need to know today. Now instead of having you copy these vocabulary words down onto your notes, turn to your green vocabulary packets that you got at the beginning of the module. If you can't find your green vocabulary packet, I do have some extras in the back of the room that you can go take. Now looking in your green notes, number 20, highlight rate. Rate is a ratio of 2 quantities, such as 5 miles per hour, 5 miles per 2 hours is referred to as a rate. So basically a rate is a ratio. So highlight the definition for number 20 and circle the word ratio because basically a rate is a ratio. Now let's keep looking on the next page for the definition of 21. The unit rate. Sometimes you'll hear it called the associated rate. The numerical part of the rate is called the unit rate. Okay, so it's the numerical part, meaning the numbers. Okay, and it's a rate where the second quantity is 1 unit. The second quantity is 1 unit. So in the case above, the value would be 5 to 2, or when converted from an improper fraction, it would be 2 to 1/2. So that means in 1 hour, the car could travel 2.5 miles. So in 1 hour. What's another word in here that sounds familiar? So when we scale our ratio down, all the way down to 1 unit, what word in that definition looks familiar? Another word for unit rate is value. Isn't that what we looked at with the ratios? When we scaled it all the way down, that was the value. So a way to think of unit rate is the value when you get it down to 1 unit. Okay? The last term for today is rate unit. So highlight rate unit. This is identified as the 2 units or labels. So basically miles per hour, miles per gallon. Okay, so it's the labels, the quantities that are being compared. So when we make our key and we put the 2 words on top, you're saying, what are the 2 things? What are the 2 things? The 2 things, that's your rate unit. And unit rate will be in tables, graphs, and equations, which we're going to look at some more today. Okay, so let's flip back to our notes. And let's practice number 1 in our notes. So Tegan went to Gamer Realm to buy new video games. Gamer Realm was having a sale. Woohoo! $65 for 4 video games.
Oh my God, yes, have it.
He brought games himself and 1 game for his friend Diego. 3, 2, 1. But Tegan does not know how much Diego owes him for 1 game. What is the unit price for the video games? What is the rate unit? So we have to be careful because they're asking us for 2 things. So it helps to highlight so we don't forget to go back and answer the 2 questions that are being asked. So what's the first step? What have we been doing? As soon as we see a ratio, what have we been doing? Let's make our T. What are the 2 things being compared? What are the 2 quantities? Gentlemen, stay with me, please. You need to take your notes. What are the 2 things? Things. What do those mean?
Video games to
We have dollars to games. 60. You said it was 65 to 4, which you are correct. The ratio is 65 to 4. 65 what? Dollars. 4 what? Games. So the first thing, let's take a look at the rate. Remember that the rate is another term for ratio. So the rate is 65 to 4. Now we have to find the unit rate. And another word for unit rate is the value. So let's think about this. Excuse me a minute. I don't know if you're Diego or Tegan. I'm moving you. So if our ratio is 65 to 4, my unit rate tells me I have to get it down to an equivalent ratio that has 1 as the second number. Okay? So I could use what? Oh, if only I knew how to do equivalent ratios. How do I do it? Oh, do you know how to do equivalent ratios? Yes. How do you do equivalent ratios? Give me one method. What can we use? Double B, multiplicative value. What's another method we could use? Suppose we don't like that one. Can we do something else? We can make a table. Suppose we don't like the table. What can we do? Double number line. What else can we do? Take diagrams. Lots of choices, which is good because not everybody likes the same method or finds it as easy. And it's so nice to have more than one method because then we could use a second method to check our work. But for now, let's use double V because of how we have it set up. So 65 to something, then 4 to 1. How do I get from 4 to 1? How do I get from 4 to 1? Ooh, lots of hands. Good. Not times it. This time I'm going to divide it by 4. Everybody said that. Last period too. That's not funny. That's a common mistake. There's absolutely nothing funny about that answer. So go. You should be dividing in your margin right now. 65 divided by 4, giggles. Come on. 65 divided by 4.
And 1/4 or 16.25.
16 points. Since it's money, let's keep it with the decimal. So the unit rate is 16.25 to 1. But what does that mean? That's where the rate unit or label comes in. Okay? So what words would we connect with that? What does that mean? What words is that? You can always come back to your T too. God bless you. That would help also.
16.25 for 1 game.
I just want words. I don't want numbers. I just want labels. So let's think about it. What does that mean? What does that mean? 16.25 what? Dollars. Dollars what? Per game. So Diego owes him $16.25 for one game. Okay, so those are your three answers. A little down. Well, we only needed two, but I started by writing the rate because I wanted to review that also. But they wanted these two, the rate unit and the unit price. Yes.
Is that 16 and 25 on this? I got 16 and 40.
Okay, those, no, because your remainder cannot be brought up as a decimal. Okay, you have to add the decimal. I'll show you later how to do that, okay? All right, at this point, we're going to switch to lesson 17. Lesson 17 is continuing along with the same process. All right, so we know how to do the ratio, the unit rate, and the rate. If we took a look at the first example, you know I like to swim. Mrs. Nocero just walked by. She used to be a competitive swimmer when she was in school too. So one thing swimmers will look at is their timing. How many laps per minute? So here, somebody was swimming at a ratio of laps to minutes is 5 to 4. Well, first we have to write that as a rate. So how would we do that as a rate? The rate is another word for ratio. So the rate is 5 to 4. Or 5 to 4. You might also see it as 5 laps per 4 minutes. You ready? They can sometimes pull out that unit rate, even though it's not real. They'll take out the rate and say it's 5/4 laps per minute. 5/4. Sometimes they'll even use a slash. 5/4 laps per minute. But that's confusing. That's confusing. 5/4 laps per minute. Wouldn't it be easier to get it down to the unit rate? How many laps in 1 minute? So let's scale that down. So our ratio was 5 to 4. What would our unit rate be? So if we have 5 to 4, and our unit rate has to get it down to 1, what would our unit rate be? What would our unit rate be? Think of the double V. That's dividing by 4. So 5 divided by 4 is what?
1.25.
Okay, 1.25. So our unit rate would be 1.25 over 1. So that's the unit rate because we got it down to 1. The rate, how many laps per minute? 1.25 over 1 laps per minute. Or you could just say 1.25 laps per minute. They have to get the fraction because remember the unit rate is just like the value. Right. Are we okay with this?
Yeah.
Don't forget, you have those green sheets with vocabulary words to help you if you need help with your homework tonight. All right. Let's apply this. Let's see how using the unit rate can help us with other equivalent ratios. So Dave can clean pools at a constant rate of 3/5 pools per hour. Wait, what? Fractions? What does that mean? Before we can go on, we have to figure out, what does that mean? What does that mean? What does 3/5 pools per hour mean? If I wanted to come over here and make my key like we always do, what does that mean? Yeah, he can clean 3 pools in 5 hours. Perfect, that's what that means. So if we're looking at pools per hour, 3 pools per 5 hours. That's what that means. So now how would I write that as a ratio of pools to hours? You should be highlighting these keywords in your notes. What is our pools per hour? What is the ratio? Yeah, a ratio is 3 to 5. That's it. We already did that in the key. All right. But it's a busy time of year, right? Fall. I mean, who's closed their pools already? Yeah, we closed ours a long time ago. No, you don't have to close it. Good. Saves you a lot of money. That's easy. So now, 3 to 5 is our ratio. But now, I don't want to know how many he's going to clean in 5 hours. How many can he clean in 10 hours? So, good thing we have lots of different methods to choose from to find an equivalent ratio that will tell me. What's one method we could use? We did double V already. Let's do something different. Let's go crazy. Let's go old school. Old school! It's Throwback Thursday! Let's go all the way back to what? We could do that too? We did one of those already. What do you want to do? We're going back. We're rolling all the way back. Let's do a tape diagram. So if we're looking at pools per hour, our ratio is 3 to 5. So remember, we set up our tape. We set up. Do my own stuff.
Stuck the landing. It's okay.
So, too bad the superintendent and principal weren't here to see that one. Okay. She could teach and fly at the same time. So we take our original ratio, and that's what we use to set up our tape diagram, gentlemen. Now, I'm given a 10. What do I do with my given of 10 hours? Does my 10 equal the first row in my tape diagram? No. Does my 10 equal the more? No. Do I have to take that 10 and divide it by 2, the more? Does my 10 equal the number of hours? Yes. So I have to take that 10 and separate it evenly among those 5 boxes. Or I have to take that 10 and divide it among those 5 boxes. So now I know that my constant is 2. Any questions on where the 3 boxes came from, or where the 5 boxes came from, or where the 10 came from, or why I put the 10 there, or where the 2 came from? Those would be some good questions to ask now. You may be, but others are not. So let's, okay, be considerate of that. What's your question?
Where did the 10 come from?
That's a great question. The 10 came from as our given. I know that he has to do 10 hours. So this whole row has to equal 10. Okay? So now, because I filled in my constant, how many pools is that? 6. So how long will it take him? How many pools in 10 hours? 6 pools in 10 hours. And that's your answer. Dan can clean 6 pools in 10 hours.
Could you use the same line as the ratio if they wanted, the number given, but it's higher? Could you use
We're still going to draw or 3 to 5.
If you wanted to make it easier.
So here we have another number, 15 pools. So even though it's a bigger number, we're still going to use our same initial ratio, the 3 to 5. So we have pools and hours. So now we have 15 pools. So we have 15 pools. So let's see where we're going to put that 15. Do I bring it down here for the hours again?
No.
Is it my more? Is it my pools? Okay, so now the 15 is going to go here because it's 15 pools. So I have to take that 15 and divide it among the 3 pool boxes. So what's 15 divided by 3? 5. So now I know my constant is 5. So when he leaves the house in the morning and he says, okay, let me see my to-do list. My to-do list has me cleaning 15 pools today.
Oh my God.
Can I get it all done in one day? How many hours is that going to be? Oh my goodness.
No.
He better get to work and he better pack breakfast, lunch, dinner, and then breakfast again. It's going to be a while. I hope he built in some potty breaks. Okay. I like going old school. I like the tape diagrams. Let's try something else. Emmeline can type at a constant rate of 1/4 pages per minute. Ugh, what does that mean? What do you mean? What does that mean? 1/4 pages per minute. What does that mean?
1 page before.
Right, she'll type 1 page in 4 minutes. Hey, Snoopy. Okay. So what is the ratio of pages to minutes? Using your highlighters. Some people still got this backwards on the quiz, on the test yesterday. Pages to minutes is what? What's the ratio? Absolutely, 1 to 4. So Emmeline has to type a 5-page article, but only has 18 minutes until she reaches her deadline. Does she have enough time? I could totally do a tape diagram, but I don't think that's going to work. That's not going to work. Double number line will work this time. Right, a tape diagram would not be as helpful. So we're looking at pages to minutes. So 1 page in 4 minutes, 2 pages in 8 minutes, 3 pages in 12 minutes, 4 pages in 16 minutes, 5 pages in 20 minutes. Now she only has 18 minutes. Will she be able to type 5 pages in 18 minutes? No. How long will it take her to type 5 pages? How long will it take her to type 5 pages? Takes her 20 minutes. So no, she won't have enough time. Bus. Okay, so no, she will not have enough time because it will take her 20 minutes to type 5 pages. And the double number line will help us answer part C for a 7-page article. So 6 pages would be 24, 7 pages would be 28.
be writing notes.
So your homework tonight is page 71 and page 76 because you have to do the problem set for lesson 16 and lesson 17.